Hello, good afternoon to all. Myself Ankit Sagar. I'm a final year PhD student at University of Lorraine and IGN. Today I'm going to give a brief presentation about the topic Multisource National Forest Inventory, a flexible tool for forest resource information and decision making. So this work was done under the supervision of Cedric Vega, who is working at IGN, and Jean-Pierre Renaud, who is working at ONF. Okay. So with the development and the recent advancement of remote sensing and GIS technology, there is an increased demand of high resolution information about forest resources, such as amount and state of forest. So this information is much needed for decision making purposes and to perform better management practices. This information is also needed, which is amplified by the ongoing climate changes, which is why, because the frequency and the severity of natural disturbances such as droughts, windstorms, insect outbreaks are increased, and these disturbances are heterogeneous in space and time. National Forest Inventory are statistical survey which are designed to produce precise and unbiased estimates of forest attributes of interest at large scale. Usually these scales are at national to regional level. And these forest attributes could be anything from like carbon, above ground biomass, growing stock volume, etc. But the sampling design of the NFI is not adapted to estimate the forest resources at local or management scale, or for some diffuse phenomenon such as these disturbances. So the researchers came up with a solution called Multisource National Forest Inventory, which basically improves the precision of NFI at such smaller scales. So this figure basically depicts the working principle of NFI, MSNFI, where NFI fill plot data, which is having high thematic precision and low spatial resolution, is combined with auxiliary data, which is coming from remote sensing or any kind of thematic maps, digital maps, which is having high spatial resolution but low thematic precision. So the output which we get from this combination is enhanced forest inventory, which is having high thematic precision as well as high spatial resolution. So one should ask like why we are working with remote sensing data, which is why, because specifically the remote sensing, 3D remote sensing data from LiDAR and photogrammetry are strongly correlated with forest structures such as volume and height. And the optical remote sensing images from Sentinel or Landsat satellites are well correlated with the species composition, maturity, vitality, and health of the forest. So this figure is basically depicting the estimation framework which has been used in MSNFI, which is flexible. So here we have listed 3 estimation framework, which is design-based, model-assisted, and model-based estimation framework, which are used for various estimation domain. So for global estimation, such as at national or regional level, design-based estimation which incorporate only NFI plots is used to produce precise estimates. And this estimation framework is design unbiased by definition. But as soon as we want to estimate, or as soon as we want to downscale this estimate at smaller areas, such as small area estimation or even like pixel level high resolution maps, we have to rely on model. For this, we have this estimation framework called model assisted and model based. So model based estimation framework accounts for estimation at model based estimation framework relies on the model itself, but there is a risk of bias here because of the model misspecification. So one should be careful while specifying the model, especially while selecting the auxiliary variable. So the auxiliary variable should be selected accordingly so that it could catch the variability of the filled attributes. So this is another depiction of estimation framework of MSNFI, in which we put emphasis on model-assisted and model-based estimation framework. Here, we are combining our NFI and auxiliary data sets using predictive model, which could be anything like linear models, parametric, non-parametric KNN models. And based on this model, we are predicting we are getting output as predictive maps, and which is complemented by statistical inference. And if we want to estimate for small areas, NFI plots are used as well. So from small area, the term small area estimation. So small area estimation is basically borrow strength from the wide coverage of the survey to the estimation in small geographical domains. So here we have used our NFI plots from all the other areas to correct the bias in this white border area, which which is our area of interest. So this is a case study which we did in Forest of Salon. We tried to estimate the growing stock volume at municipality level. So we have used NFI data sets. We have combined NFI data with airborne LiDAR and Landsat images using KNN models. So the average error we obtained here was 15%, and the variance was reduced by a factor of 5 compared to design-based estimates. So the black area which you see in these maps are the areas where no NFI plots were available. So one should ask like how to estimate in this area. So we came up with a solution called multi-scale model assisted approach, in which instead of estimating in one municipality, we combine or we group the municipality based on the number of NFI plots available in it or its surrounding. So here our average error was around 7.5% to 15.1%, and the variance was reduced by a factor of 3 to 4. So this is a case study on the same study area using same data sets. We are working for high resolution maps. So we built pixel level maps at a spatial resolution of 30 meter. So we predicted growing stock volume here using KNN model. So we used bootstrap predictions, which is the basis of model-based estimation. And the first figure which you see here is the growing stock volume at 30 meter. And subsequently, we provided a map of reliability of this prediction, like how reliable these predictions are. So this computation of reliability was calculated using the computation of precision, which comes from the model and prediction errors, and we computed the accuracy using a novel approach using convex hull. To compute the accuracy, we combine this precision and accuracy map to provide reliability maps. So coming back again to small area estimation, so we again applied this small model-based estimation in context of small area estimation to estimate the bark beetle impacted area in the forest of Vosges. So we have used here KNN maps, like the KNN maps which we produced at 30 meter. We combine this map with the map of damaged area, and in the forest of Vosges we came up with the number of 0.3 to 0.0 million meter cube of growing stock volume were affected, and out of this number 77% of the predictions were reliable. So finally, so the approach we built is flexible, which can be adapted to various user needs. So if one wants to go for precision or policies, model assisted is well suited, such as for municipality level. If one wants to go for spatial resolution or for management and event disturbances, model-based approach is much suitable. High density LiDAR program is well suited for MSNFI approach because the digital terrain model and canopy height model derived from LiDAR are very accurate. But the problem with LiDAR is like it's a little bit expensive, so we came up with an alternative called photogrammetry, like aerial images, which is cheap and given a good digital terrain model is available. It could be operational. It is actually operational in many NFIs, and 3D data and models for digital twin of forest. Thank you for your attention. If you have any questions.
Thank you very much. Est-ce qu'il y a des questions dans la salle?
I was wondering, what is the temporal, how many, alors je vais la faire en français, désolé. Quelle différence temporelle vous avez utilisée entre deux images? Est-ce que c'est 1 an, 2 ans, 3 ans pour mesurer la croissance? Est-ce que c'est moins, est-ce que c'est même interne à l'intérieur d'une année?
How many time between two images? 1 year, 2 years, some months?
Which image you're talking about? So for the so for estimation in Salon or even in Vosges, in Salon, we use just we don't rely on temporal time period of the satellite images, but for the Vosges we rely on this temporal gap of 3 years.
Une autre question? I have just one. You use the KNN model technique, but why this one? Is there other techniques you can use?
Yeah, there are other techniques which we can use, but we choose to work with KNN because it's multivariate in nature, meaning that you can estimate multiple forest attribute in a single model.
Thank you very much.
Thank you.
There is another question, perhaps? We have some time, so it's okay.
Thank you. What is the minimal scale of unity of space that you were able to address with this method? Because I know that today in France we are doing more and more atlas of biodiversity at a communal or inter-city scale. So it looks a bit like the scale you were addressing in the second test, where you were trying to fill the gaps of missing data. So do you think it could be an interesting potential use of this technique to match the scale of biodiversity sets of inventory you'll have in France? If it could match the scale, it's interesting, because then you have these units of territory where you can describe, for instance, health of forest, but it could be anything else.
Yes, exactly. But the minimum scale which we choose here is 30 meter of spatial resolution. It's because it is well suited with the plot diameter of NFI, if I understand you correctly.
30 meters?
Yes.